Okay, in the previous video we had solved pin jointed frame. We had analyzed the pin jointed frame using the stiffness matrix. So in that problem there were only two members which are connected at a joint A, right? At B, sorry. So in this problem we are going to solve a pin jointed frame which is having 5 members, member AB, AC, AD, AE and AF, which are connected at a joint A. Okay, as you can see at joint A, it is subjected to a load of 100 kN which is acting at a angle of 60 degree with respect to X. Okay, now we can solve how much is the component of 100 kN in X and Y direction. So if you solve 100 into 50, you will get to know how much is your load which is applied in the X direction, which is 50, and similarly 100 into sine of 30 will give you how much is the load which is acting in the Y direction. Okay, now after looking into this frame you can say that the length of the members are not written here. So we do not know how much is the length of member AC, AD, AB, AE and AF. So what we can do is we can consider that the length of the member AD as L, and we can solve how much is the length of member AB, AC, AD and AEF. Okay, let us try to resolve how much will be the length of member AB. So to solve the length of member AB, what we should do is we need to consider this L. So this will be a triangle. So in this triangle, this is your hypotenuse, this is your opposite to this angle which is 45 degree. So sine of 45 degree, or let me call it as sine of theta. So sine of theta will be equal to L divided by LAB. So this is your L divided by LAB. Now if I tell you to solve how much is LAB, LAB will be equal to L divided by sine of theta which is 45 degree, and if I solve I will get to know how much is LAB. LAB is 1.414 times of L. Okay, similarly I can also solve for AC, which is 1.154 times of L. Here sine 60 degree will be equal to L divided by L of AC, so we can calculate how much is LAC in terms of L. Okay, so we already know what is the length of AD. So length of AD member is L itself. So as we know that these two members are symmetric in nature, so the angle over here is 60 degree for AC. Similarly for AE also it is 60 degree. So this length will be also equal to 1.154 times of L, and this will be 1.414 times of L. So once we determine what is the length of all the members in terms of L, the next step is to solve for stiffness matrix. Okay, so let us solve the stiffness matrix. To solve the stiffness matrix, as we know, we need to write this table. So in the first column it will be of members that are connected at any given joint. So as I told you in the previous video also, in this frame also we have only one joint which is moved to free, and it is having 2 degree of freedom, which is first coordinate, and the other one is second coordinates. This will remain same. Okay, now so we have 2 coordinates at the joint A and there is no other joint. So that's why we will consider only first column as member itself. So the members which are connected at joint A will be AF, AE, AD, AC and AB. So all these members. Okay, now similarly we can write how much is AE by L for all the members which we have recently calculated. So we know that AE is going to remain constant, the only change will be the length. So AE divided by the length of member AF. How much is the length of member AF? It will be 1.414 times of L. So AE will be divided by 1.414 times of L. I have not just repeated all of those words here. So as we know that the numerator is remaining constant, I have not written it. Okay, in your notebook you can write over there. Just to make this table very clear and very watchable, I have not used this AE by L, though the AE by L exists in all the terms. So this will be called as AE by 1.154 times of L. This will be AE by L. This will be again AE divided by 1.154 times of L. This will be AE divided by 1.414 times of L. So these are all the AE by L values which I have written. The next step is to write the theta values. So I told you how to write the theta values. You should write the theta values with respect to the first coordinate that you consider. If this is your first coordinate, so we will go to AF. AF is at 45 degree and AE is at 60 degree. Now if I take AD, AD is at 90 degree. Now when you go to AC, AC is from here to here, which is 120 degrees, and AB is at 150 degrees. So this is your theta values. Okay, so once you write down all the theta values with respect to the coordinate, first coordinate, which is your X direction, next thing what we do is we calculate the cos of theta. So let us take the cos of theta of all these values. Okay, next we will take the sine of theta of all these values. So once you solve AE cos theta sin theta, the next step is to find out k11, k22 and k21 and k11. Okay, so this column gives you what is your k11. So let us solve AE into cos square theta divided by L. So AE by L, which we already know, this should be multiplied by cos square theta, and it is written here. Now I don't want to repeat it every time in this column as AE by L, so I have written only for the first term. So 0.353 into AE divided by L is there. Now this will repeat for all the terms. So 0.2166 into AE by L, this is 0. Again similarly 0.2166 into AE by L, and this will be 0.5353 into AE by L. Okay, these are all solved by multiplying AE into cos square theta. Okay, now once this is completed, we can solve for the next column, and the next column what we do is we multiply AE by L into sin square theta. Okay, so we are solving AE by L into sin square theta values. The next step is to multiply the column AE by L into cos theta into sin of theta. So we need to multiply these three values and write down in this column. So once we solve all these terms, once we complete solving all this table, the next step is to take the sum of AE into cos square theta by L, which is your k11. Then we need to take the sum of AE into sin square theta by L from this column, and we have to find out how much is k22. And if I take the sum of all these values, which is AE into cos theta into sin theta divided by L, it will give me the value of k12 and k21. Okay, so k11 will be this summation of this column, which is 1.1402 AE by L. K22 will be the summation of this, which is 3.007 AE by L. K21 and K12 is equals to 0. Okay, so once we solve this, we can write what is our stiffness matrix. So stiffness matrix, in which I have taken AE by L as common, so our matrix will be this 1.140200 so this completes our stiffness matrix. So once we have solved the stiffness matrix, the next step is to solve for force matrix. So while for solving the force matrix, as we knew, the force which is applied at the joint A was 100 kilonewton, the external load which is applied. We have resolved it in x direction and y direction. So whatever the component of 100 kilonewtons is acting in first coordinate will be written as the first coordinate force value. So the force at first coordinate is 50 kilonewton, and we know that at joint A, the component in the y direction is in the negative y direction, so it is minus 86.6. So minus 86.6. So we have solved the stiffness matrix, we have solved the force matrix. What we do is we take the inverse of stiffness matrix, multiply with the force matrix, and write down how much is your displacement. So there are two displacement which are solved. What is those displacement? We have solved the displacement of joint A in x direction, and we have solved the displacement of joint A in y direction, which are these values. So once you solve the displacement, next step is to find out the forces. So we can start from this side or this side. Let us start from this side. So I am calculating how much is the force in the member AB. So for calculating the force in the member AB, first we will write down the equation. So what is the equation we need to write? For member AB, at the joint it is connected at A, and at the far end it is B. So AE by LAB. What is the length of member LAB? We already know, which is 1.414 times of L. Right. So now in this equation it will be dBx. dBx is what? Displacement at B in x direction. What is dAx? dAx is the displacement at A in x direction. We know that dBx is a fixed end, so that's why dBx and dBy will be equal to 0. So dAx will be multiplied by cos of theta AB, which we know, and similarly dAy is multiplied by sin of theta AB, which is written over here in the table. So referring this table and substituting the values of cos of theta, sin of theta, and substituting the value of dx and dy in this equation. So after solving all these, we can similarly solve for AE and AF. So the force in the member AE and force in the member AF is written over here. I have not solved it on the board. What you can do is you can solve these values and try to confirm whether you are getting the same values or not. For force in member AE, we are getting 2.61 kilonewton. The force in member AF, we are getting minus 7.525 kilonewton. So you try to solve these values, and if you find any difficulty in solving this, you can ask me the question. So I'm going to solve another problem on the pin jointed structure itself. So if you find any problem which is difficult for you to solve, and if you found any question in the previous question papers which you are not able to solve, you send it to me so that I can solve it and I can send those solutions through making them as videos. Okay, thank you.